Hi everyone, so this is lesson 3.5, which is the unit circle part 1. Now lesson 3.5, 3.6, and 3.7 are all the unit circle. But the unit circle is a lot of information that all kind of spirals together and builds on each other, and so that is why we split it into parts 1, 2, and 3 in lessons 3.5, 3.6, and 3.7. So this is just the first part of the unit circle. And today what we're going to do is we're going to try and wrap our minds around what the unit circle is, make sure we're really comfortable with degrees and radians, and really dig into those special right triangles that we have been focusing on so much, especially in lesson 3.1, the 30, 60, 90, and the 45, 45, 90. So first what I want to do is if you have some different colors, it would be good to notice the different colors that I have and how I've organized my circle here in my notes with these colors. They're going to be important here in a few minutes as we go through and we label degrees and radians through this circle. So first what I want to do is I want to go through and label the yellow, so in degrees. So I know in the yellow that if I had no rotation at all in standard position, this would be 0 degrees. Up here in my positive y-axis, this would be 90 degrees. Over here in my negative x-axis, that would be 180 degrees. Down here on my negative y-axis, that would be 270 degrees. And one full rotation is 360 degrees. So there is my yellow. Now what I want to do is I want to go the blue. Notice in these blue lines, they are exactly halfway in between each quadrant. So this blue here, if I were to go halfway between 0 and 90, that would be 45 degrees. Another 45 degrees would put me at the 90 degrees. 90 plus 45 would put me at 135 degrees. 135 plus 45 would be the 180. 180 plus 45 would put me at 225 degrees. 225 plus 45 puts me at 270. 270 plus 45 puts me at 315 degrees. And if I were to add 15 more degrees, that would put me, 45 more degrees, that would put me at 360, a full rotation. So those are pretty simple. So now is where, the next one is where I'm going to rotate 30 and then 60 degrees. So this red is going to be 30 degrees. If I were to go another 30 degrees, I would land at 60 degrees. So here I'm going to be switching colors because, and you'll see in a minute when I go with the radians, but so I'm basically just going to go out measures of 30 degrees and I'm just going to keep my colors. So I've got 30, 60, 90. If I add another 30 degrees, I'd be at 120 degrees. If I go 120 plus 30, I'm at 150. Another 30 degrees, I'm at 180. Another 30 degrees, I'd be at 210 degrees. If I went another 30 degrees, it'd be 240 degrees. 240 plus another 30 puts me at this 270. 270 plus another 30 puts me at 300 degrees. And then 300 plus 30 puts me at 330 degrees. And one more 30 puts me at 330 degrees. So what I want you guys to see is the different colors. And now, as we change these into radian measure, hopefully you see some patterns. So first, let's talk about the first quadrant here. 30 degrees, if I were to change this into radians, I'd multiply by pi over 180. My degrees would cancel, and I'd end up with 3 over 18, which is 1 over 6. So pi over 6 radians. If I change 45 degrees into radians, I can do my quick conversion. I know that 45 goes into 180 4 times, so I'd have pi over 4 radians, a fourth of a pi. And then here, if I take, I'm going to erase this here in a minute, but 60 degrees times pi over 180. My zeros would cancel, my degrees would cancel, and 6 over 18 is a third. Pi over 3 radians. So if I think about this in terms of a pi, we know that 0 degrees is 0 radians as well. I know that 1 full rotation is 2 pi's. That means 90 degrees is pi over 2, half a pi. 180 is 1 pi. 270 is 3 pi over 2, or 1.5 pi's. And so there's my 4 corners in my yellow when I convert those into radians. So now let's think about, let's do the blues first. So if I have 0 radians here in my first yellow, my positive x-axis, and I go to my blue, which is right here, pi over 4 radians. If I went another 45 degrees or pi over 4 radians, that would land me here. Realize that this pi over 2 is equivalent to 2 pi over 4, but we would simplify that to be pi over 2. If I go out another pi over 4, well, that would be 3 pi over 4 radians. If you want to check behind me, you can do the conversion and multiply 135 times the pi over 180. You'll get 3 pi over 4. If I went another pi over 4, this would put me at the next yellow line, which would be 4 pi over 4. But of course, that simplifies to just pi, right? Let's go another pi over 4, my next blue line here. Well, that would be 5 pi over 4 if I add a pi over 4. Let's add another one. That would be 6 pi over 4. But of course, that simplifies here to 3 pi over 2. Let's go one more. That would be 7 pi over 4. Now I'm here at this blue line. 7 pi over 4. And last, I end up at my yellow line when I add another pi over 4, and that would be 8 pi over 4. But that simplifies to 2 pi. So now I can see I've converted all the blue lines into pi over 4s, and I see the yellow lines, they all simplify. Let me go ahead and I'm going to erase these extra blues because we're going to see, I might need a little bit bigger of an eraser, because we're going to see more of where that came from whenever I go with my yellow and my green lines, how those simplify as well. But now I have all my blue lines done. Now what we're going to do is we're going to go out by measures of 30 degrees or pi over 6 radians. I'm going to need a little more space. I'm going to get rid of all of this work that I did earlier. Alright, so if 30 degrees is pi over 6 radians, let's go out another unit of 30 degrees or pi over 6. So if I were to go out 30 more degrees, that would land me at 60 degrees. So I'm starting here at 30 degrees, pi over 6 radians. If I were to go out another unit, that would land me here at the 60 degrees, or pi over 3. That would be 2 pi over 6. So I started here with 1 pi over 6. Now I'm at 2 pi over 6. But that simplifies to pi over 3. If I were to go another 30 degrees, or another pi over 6, that would be 3 pi over 6. But of course that simplifies to pi over 2. If I were to go another, that would be 4 pi over 6. If I go another 30 degrees or pi over 6 radians. But that's interesting because I know that that is going to simplify to 2 pi over 3. Let's go out another. When I'm at the 4 pi over 6, that would be 5 pi over 6, and I'm at the 150. And that doesn't simplify at all, so I'll leave it. Next, I would go down, I'm at the yellow line now, that would be 6 pi over 6, which simplifies to just a pi. Another pi over 6 units, or 30 degrees, and I got 7 pi over 6, which doesn't simplify. Now I'm going to go out another 30 degrees or pi over 6, and that puts me at 8 pi over 6. Well, that does simplify to 4 pi over a 3. Now I'm down here at the 270 degrees, or the 3 pi over 2. That would be 9 pi over 6 if I add another pi over 6. but that simplifies to 3 pi over 2. Now I'm going to go another 30 degrees or pi over 6 units. That would be 10 pi over 6. And that simplifies as well. That simplifies to 5 pi over 3. And then last, 330 degrees would be 11 pi over 6, which does not simplify. And finally, one more pi over 6, which is 12 pi over 6, which simplifies. So as you can see, I want you to look around at these patterns as I went through one complete rotation going out 30 degrees or pi over 6 radians. And notice that everywhere I was red, look at those denominators. They are all something over 6. Then look at all the greens. I have pi over 3 here. It was 2 pi over 3, but it simplified to 2 pi over 6, but it simplified to pi over 3. Notice the 120, it simplified to 2 pi over 3. Down here at 240, simplifies to 4 pi over 3. And the 300 simplifies to 5 pi over 3. So I'm going to go through and clean this up a little bit. I want to get rid of all of the simplifications, and I only want to put the most simplified answers. Get rid of all of those. So basically the greens are where I gotta go, and the 4 corners where we pointed those out. Grab my green pen. And fix these up. So I also want to point out one thing. If I were to go out pi over 3 units or 60 degrees, notice 60 degrees is pi over 3. So if I were to jump 60 degrees, that would land me here at 120. That would be one more. Pi over 3 plus pi over 3 is 2 pi over 3. If I go out 60 more degrees, I'm down here now. That would be 3 pi over 3. So down here is 4 pi over 3, which we saw when we simplified when we were going out by units of 30 degrees. So down here, if I go another 60 degrees, that lands me here at 300. That's my 5 pi over 3. Go another 60 degrees, I'm at a full rotation. That would be my 6 pi over 3 or 2 pi. So some big ideas here that I want you to notice. Take a look at all the red line denominators. You're over 6 here at all your red lines. Blue lines, all my denominators and my radians are over 4. Green lines, all my denominators are over 3. And hopefully this helps solidify how these radian measures are working when you're just taking fractions of the pi or the 2 pi. So now the next question is, why do I care about the 30, the 45, and the 60? Well, it's because of my special right triangles. Remember, we've got the special 30, 60, 90 triangle. Let's review those ratios in degrees. I know that every 30, 60, 90 triangle has these ratios set up where if I know the short leg, I can find the long leg and the hypotenuse really easily. If I was going to evaluate trig functions, then I know that all the ratios are going to hold. So remember, I can set the short leg to just be 1. And when I do that, I have this kind of unit triangle where there's a triangle that exists where the short leg is 1, the long leg is the square root of 3, and the hypotenuse is 2. And I can evaluate all the 6 trig functions of 30 and 60 degrees just by knowing these ratios. And now I also know that 30 degrees is pi over 6 radians, so I know I could evaluate all the 6 trig functions of pi over 6 radians, and I know 60 degrees is pi over 3, so I can evaluate all the 6 trig functions of pi over 3 radians, and they would be the same thing. Just to show you what that would look like, if I wanted to know what is sine of 30 degrees? Well, I would go to my 30 degree angle, and I know sine is opposite over hypotenuse, and that opposite side length is 1. and the hypotenuse is 2. So I know sine of 30 degrees is a half. That also means if I said, well, what is sine of pi over 6 radians? Well, pi over 6 is the same thing as 30 degrees. So sine of pi over 6 is also 1/2. It doesn't matter if I'm going to be measuring in degrees here or radians here. They are equivalent angle measures. So I didn't just know the 30, 60, 90. I also knew, let's go over here, the 45, 45, 90. So let's review that one really quick. So those were, if I knew the legs, which have to be the same length, I know that the hypotenuse is equal to the leg times the square root of 2. So what I can say is set that leg length to 1, and I know the trig ratio will hold, meaning the legs will have a length of 1 and the hypotenuse will just have a length of the square root of 2. And now I can evaluate any trig function of 45 degrees just by knowing this triangle. And since I know pi over 4 is the same thing as 45 degrees, I can also do all the 6 trig functions of pi over 4 radians. Okay, let's look at a little more in depth with this unit circle. So let's define the unit circle. The unit circle is a circle centered at the origin with a radius of 1. Ooh, I don't know why that got so big. Hold on. So a circle centered at the origin with a radius of 1. You can look directly below where I see consider the angle 30 degrees or pi over 6 radians in standard position, and you can see that I've got a picture of a unit circle here with centered at the origin here with a radius of 1. So you can see if there's a radius of 1, this right here is the point 1, 0. Up here on the y-axis, 0, 1. Back here, negative 1, 0. And down here is 0, negative 1. And that's just coming because the radius has to be 1. So if I have an angle of 30 degrees or pi over 6 radians in standard position, what I want to do is I want to go out in standard position that angle measure. So this would be 30 degrees down here with my x-axis. And I want to drop a perpendicular and make a right triangle, dropping this right here to make a perpendicular line to the x-axis and create this right angle. So this right here is a point on the unit circle. Now, because I know a little bit about right triangles, I have a right triangle over here, up here in my gray, I know that every single 30, 60, 90 triangle has a ratio of 1, root 3, and a hypotenuse of 2. I know this would have to be 60 degrees because I know that all 3 angle measures have to add up to 180 degrees. So think about this. In this triangle right here, I know the radius here has to be 1. I know this because it's a unit circle, and so from the origin to any point has to be equal to 1 unit. Now, because I know this, I know this length right here is my short leg, and this is my hypotenuse. Well, think about the relationship between the hypotenuse and the short leg. If I were to add my x's in here, you might have to add your x's if that helps you see it. I know that the hypotenuse is always twice the short leg. So if my hypotenuse here is 1, well, my short leg has to be a half. Does that make sense? Because I know 1/2 times 2 would be 1. And I also know that my long leg is always equal to the square root of 3 times the short leg. So my long leg here would be equal to the 1/2 times the square root of 3, which would just be the square root of 3 over 2. So what I've done is I've taken this triangle that I have on my right in my gray, and I've scaled it by a half. I've shrunk it down so that it fits in this unit circle. And what that allows me to do is it allows me to find this point right here. If this point is a point on the unit circle. It's just an ordered pair. And to get to that point from the origin, I would travel to the right, root 3 over 2 units, and then I would travel up a half of a unit. So this point right here sits on my unit circle. If I go out 30 degrees, and I use that 30, 60, 90 triangle to see what that point would have to be. Now those ratios should look somewhat familiar to you. I've seen that root 3 over 2 before, and I've seen that 1/2 before. If I were to draw a right triangle, a 30, 60, 90 triangle, and I'm just going to draw it kind of in standard position here with my trig ratios. I want you to notice that if I'm looking at 30-degree angle, just 30 degrees, the sine of 30 degrees, opposite over hypotenuse, is a half, and the cosine of 30 degrees, adjacent over hypotenuse, is the square root of 3 over 2. This is going to be important later on. I want you to notice that the square root of 3 over 2, it corresponds to the x coordinate in that point, and this 1/2, it corresponds to the y value in that point. So the cosine of 30 corresponded to the x, the sine of 30 corresponded to the y value when I'm looking at this point. It's called a terminal point for 30 degrees, or pi over 6 radians. So that's something that is important. You might see this pattern reappear. So we know that 30 degrees, or pi over 6 radians, is important, but there were 2 other angle measures that are important. The next one is 60 degrees. You guessed it, 60 degrees. So now let's go out 60 degrees in standard position. So I'm starting at the origin. Here's my initial side. If I were to go out 60 degrees, well, that would be up here. This was 60 degrees, it'd be a little higher. Same thing as last time. I'm going to drop a perpendicular line to make a right triangle, making this top 30 degrees, and I kind of have a representative triangle over here with my 60 degrees, my 30 degrees. So now notice that my short side is down here at the base, my long side is square root of 3, and my hypotenuse is still 2. And now my radius here, from the origin to this point on this unit circle, this will have a unit of 1. So kind of the same idea. If my hypotenuse is always double my short side, well, then I know my short side has to be equal to a half. And this is my short side because it's across from the 30-degree angle. And then if my long side is always equal to the square root of 3 times my short side, well, it would be equal to the square root of 3 over 2. So this point right here, this point on the unit circle, to get there I'd have to move right 1/2, that would be my x-coordinate, and then I'd be moving up the square root of 3 over 2, that would be my y-coordinate. So that would be the point that's on this unit circle. Again, these 2 triangles, the one that I have over here and the one that I have right here within my unit circle, they're called similar triangles because they have the same ratios. The one here in my unit circle has literally all the side lengths have been divided by 2 so that they shrunk down and fit. So if you notice this terminal side, what I want you to do is draw another conclusion with me. If I were to take this 30, 60, 90 triangle, I'm just going to keep it as it is, but I want to focus now on the 60 degrees right here. So if I were to say, what is the sine of 60 degrees? Well, that's equal to the opposite, which is square root of 3 over 2, my hypotenuse. And if I were to look at the cosine of 60 degrees, or pi over 3 radians, that would be equal to adjacent, which is 1, over the hypotenuse. Now take a look at these and look at that terminal point. Notice the sine corresponds to the y-coordinate right here, and the cosine corresponds to the x coordinate right here. And that was the same, here, this is the terminal point. That is the same pattern I saw for the 30 degrees. Notice that they were flip-flopped, but you still have the sine corresponding to the y value and the cosine corresponding to the x value. All right, next what I want to do is take a look at this 45-degree angle, or pi over 4 radians, and this will be my last one for this lesson. We're going to cut it after this and let all of this marinate for a day. So now what I want to do is I want to go out 45 degrees, starting with my initial side. And that would put me exactly halfway, 45 degrees. I'm going to drop a perpendicular line to create a right triangle. And I'm curious to know what this terminal point is on the unit circle. I know this hypotenuse is 1. And let's go back and review for a 45, 45, 90 triangle. I know that the legs would each have unit lengths of 1, and that the hypotenuse, if the legs were each 1, would just be the square root of 2. So this one's a little trickier, so I might add my x's in here. If you want to add 1 times x, and x, well, what on earth would the side lengths be? I know they'd have to be the same. Well, I know that if the hypotenuse is 1 here in my unit circle triangle, and that is going to be equal to whatever that short side is, here and here, times the square root of 2, well, what would I do to get that x by itself? Well, I would divide by 2. So I'd have x is equal to 1 over the square root of 2. That would be the length of each of those sides in my unit circle triangle. But of course, I'm not allowed to leave it like that, so I've got to simplify it, leaving me with the square root of 2 over 2. So that's going to be, I'm going to get rid of these x's right here. So I can see each of them have a length of root 2 over 2, meaning this terminal point, to get up here, I'd have to move right root 2 over 2 units, that's my x coordinate, and then up root 2 over 2, that's my y coordinate. Let's take a look at my special 45, 45, 90 triangle. My 1, 1, root 2 ratio. And let's take a look and draw some comparisons. If I'm looking at this 45-degree angle, if I were to figure out, well, what is the sine of 45 degrees, or pi over 4 radians? Well, that would be opposite side, which is 1 over the square root of 2, which I see right here, which of course simplifies to the square root of 2 over 2. If I were to look at cosine of 45 degrees, that would also be 1 over the square root of 2, because the adjacent side is also the 1, and that simplifies to the square root of 2 over 2. Now, since these are both the same value, you can't exactly see the pattern, but I'll spoil it for you. The sine does correspond to the y value here, and the cosine corresponds to the x value here. This is going to be very important moving forward, that you see that the sine values, as we looked through these, especially the 30, 60, 90 examples, sine corresponded to the y value and the cosine corresponded to the x value. So the last thing I want to leave you with, you should have the backside of this paper. So what I want you to do is take just a minute. I can do this. I want you to draw a 30, 60, 90 triangle. Just your base ratios. Kind of the unit 30, 60, 90 triangle and a 45, 45, 90 triangle. I want you to evaluate all 6 trig functions of 30 degrees, or pi over 6 radians. I want you to evaluate all 6 trig functions of 60 degrees, or pi over 3 radians. And then I want you to evaluate all the 6 trig function of 45 degrees, or pi over 4 radians. So I want you to pause the video, evaluate all 6 trig functions of those degree/angle measures and radian measures, and then come back and check your answers, and then you'll be all done with the lesson. Okay, so hopefully you can check your answers here and you see that you have the same answers that I do. I did go ahead and I wrote all my angle measures in radian measure just so that you can get used to seeing that instead of the degrees, and so you get more comfortable with those radian measures. So first I have sine of 30, or pi over 6 radians. You can see all of those ratios. Make sure you simplify where necessary. It was necessary on tangent and secant. Everywhere else didn't need any simplification. Next you'll see 60, or pi over 3 radians. I want you to take a look and see if you see any patterns. You should notice that your sine and your cosine switch, since I switched my reference angle from this 30 to the 60 degrees, so those switched, which means the cosecant and secant also switch places. And you also should notice that the tangent and the cotangent flip-flop too. But those ratios are all of the same ratios, they're just in different places. And last, for the 45 degrees, or the pi over 4, I'm now looking at this 45 degree angle measure, or pi over 4 radians, and hopefully you guys got those right answers. And you notice that I see those terminal point ratios again coming up in my sine and my cosine for each of these. So this concludes the unit circle part 1, and hopefully you guys feel comfortable with everything.